Indian cadets, by the grace of Almighty, all of you are well, wherever you are with your family. I hope you stay home, stay fine, and stay safe. In the COVID-19 pandemic condition, BARISHAL CADET College arranged online class. Dear cadets, always maintain social distance for your safety. I welcome you to my online class of class 11. Here, today's subject is chemistry first paper, chapter 2. Name of this chapter, qualitative chemistry. Now, dear cadets, enjoy the picture and think what will be the topic of this lecture today. Beloved cadets, topics of this lecture today, different atomic models. At the end of this lesson, you will be able to compare between the model of Rutherford and Bohr to explain different shells and subshells, energy level, to apply and analyze the electronic configuration of atom. Key points of this lecture today: orbit, orbital, electromagnet, transition, shell, and spectrum. At first, the model for an atom is developed by Ernest Rutherford by considering alpha particle experiment with gold foil. Here, the apparatus for alpha particle experiment. Alpha particle is the helium nuclei where if two electrons are emitted from helium atom, in that case it is called helium nuclei. Then this nuclei hit on the screen and recorded. From this result, he developed an experiment. It is called alpha particle experiment or gold foil experiment. Dear cadets, for this experiment, we need zinc sulfide screen, thin gold foil, lead block, radioactive substance which emits alpha particle, slit which indicates the straight line where alpha particles goes, then detector. Most of the alpha particles passes through, so many of the space of alpha particle are almost vacant. But few of the alpha particles are bounced back. Here, from 20,000 alpha particle, only one alpha particle is bounced back. There is a positive center of nucleus whose diameter 10 to the power minus 13 centimeter, comparing the diameter of the atom 10 to the power minus 8 centimeter. Here passes alpha particle towards the atom. Many of the alpha particles are passes through a straight line, some are deflected, and few of the alpha particles are bounced back. Here, This is the Rutherford's apparatus, where alpha particle is created and goes towards the gold foil, and result is like that. Source of alpha particle, gold foil passes of the path of alpha particle. What he expected from his experiment, the passes of the alpha particle will be straight, but what he got? Here, the passes of the alpha particle should be straight, but in real case, some of the alpha particles goes through a straight line, some are deflected, and some are bounced back. Here, first one, alpha particles bounced back. Next one, passes through. Third one, attracted by the particles in the atom. Last one, deflected. These are the result of the alpha particle experiment performed by Ernest Rutherford. Dear cadets, where is the nucleus located? This is the first question for you. Second one, charge of nucleus, and last one, alpha particle. Nucleus located in the center of an atom. Charge of nucleus, because only protons are existing in the nucleus, so charge of nucleus is positive. Alpha particle, this is the helium nuclei. Based on this experiment, Rutherford came to conclusion, and the conclusions are: first postulates, the atom is mostly vacant space. So 10 to the power 5 times of the area of atom is vacant comparing to the center of atom where nucleus is located. In the nucleus, there is a positive charge. Here, proton and neutrons are exist, and in the center, dense particle of the atom is called nucleus. Here, electrons are distributed around the nucleus, where most of the space of the atoms are occupied. He also explained that the atoms are electrically neutral because number of particles of positive particle and negative particle, that means proton and neutrons, are equal in an atom. Centrifugal force and centripetal force of electron and nucleus is equal. For this reason, stability of atom is gained, but it has some limitations also. He compared this model with solar system. For this reason, this model is called solar model. But planets in the solar system are electrically neutral, but in nucleus, positive charge contain proton, and in the outer space, electrons, negative charge containing electrons are revolving. He did not also give any idea about electrons. How can it revolves? According to Maxwell's stability of atom, if the opposite charged particles are revolving, they attract with each other and goes towards the center of the nucleus. And the stability of atom in the universe is in trouble. In the next, most accurate atomic model is Niels Bohr atomic model. He introduced orbit, and spectra. In 1913, he shown that the spectra is found from the transition of electron by considering one electron containing atom hydrogen, and his atomic model like that there is a specific circular path. Gradually we discuss about it. The postulates of Bohr's atomic model, here electrons are revolving around the nucleus in a circular path or orbit. It is called energy level. Angular momentum of an electron in a definite energy level is mv(r) equals to nh by twice pi. Mass of electron, velocity of electron, radius of the orbit. Constant, Planck's constant. N is the number of orbit. Electrons can change its position or energy level by absorbing or emitting energy. If it absorbs, goes towards higher energy level. If it release, again back to its original energy level. But it has some limitations also. It cannot explain the spectra of atom which contain more than one electron. But it can explain only the atom which contain an electron. Here, it can explain the spectra of hydrogen atom only. When electron transform from one energy level to another energy level, there is a single line is found, but in really several sensitive lines are found, but it cannot explain the source of these fine lines. He also explained the area of orbit is circular, but in case sometimes the shape of orbit will be oval. From that experiment, accurate atomic model, that means Niels Bohr atomic model, electronic configuration of the atom is developed. Electrons orbit nucleus like planets orbit in the sun. Here, this is the orbit. This is the center nucleus. This is the first orbit. This is second orbit, where electrons are revolving. In case of carbon, in the first orbit 2, next orbit 4 electrons are revolving. In case of potassium, in the first orbit 2, second orbit 8, third orbit 8, and in the next orbit, last 1 electron are revolving. Here, we know in the first orbit 2 electrons can exist, second orbit 8, and third energy level 18 electron can exist. In a specific shell, maximum number of electrons can exist. Here in case of lithium, there are 3 electrons. In the first orbit 2 electron, and in the second orbit last one. Electrons are revolving in different orbit. In the first shell, maximum 2 electron. In the second shell, maximum 8 electron. And in the third shell, maximum 18 electrons can exist. In case of helium atom, there are 2 electrons in the first orbit. These 2 electrons are revolving. This is on and this is another one. Now, dear cadets, draw the electronic configuration of hydrogen, boron, and magnesium. In case of hydrogen, in the first orbit, only 1 electron. In case of boron, there are 5 electrons. In the first orbit 2 and the next 3. In case of magnesium, there are 12 electrons in the first 2, next 8, and in the higher shell there are 2 electrons are revolving. Now, find out the number of photons, number of neutrons, number of electrons, atomic number, mass number, electronic configuration of the element which is given. It is bromine, number of photon 35, mass number 80. Here there is no charge on that atom, so this is the also electron number. Now, number of protons 35. Think and write down the answer. Number of neutrons 45. 80 minus 35 equals to 45. Number of electrons 35, because there is no charge on that atom. Atomic number 35, mass number 80. Now draw the electronic configuration. We will discuss later. Atomic structure can be developed by considering electronic configuration and by using dot and cross signs also. Here in the previous we discussed by using dot sign. Now we discuss by using cross sign. Here the electronic configuration of calcium 2882, in case of sodium 281, in case of oxygen 26, in case of chlorine 287, in case of silicon 284, in case of boron 23. This is the electronic configuration of the 6 elements which are given here. By considering different energy level according to Niels Bohr atomic model. Here is the nitrogen. You can use the electronic configuration by using cross sign also, but in previous we use dot sign. Here this is the chlorine and oxygen. Oxygen 2, 6, chlorine 2, 8 and 7. This is the electronic configuration of chlorine. In the previous we discussed bromine, but there is increase only on energy level for bromine than chlorine. Now maximum electron bearing capacity of in different orbital. For s orbital it can exist 2 electron only. For p orbital maximum electron bearing capacity 6. For d orbital 10 and for f orbital 14. Again, different orbitals are divided in different suborbitals. For only on s. For second shell 2 suborbital 2s and 2p. For third shell 3 suborbitals 3s, 3p and 3d. For fourth shell 4 suborbital 4s, 4p, 4d and 4f. For first shell these 2 electrons in 1s only. For second shell these 8 electrons divided in 2 subshells 2s2, 2p, 6. This is the maximum condition. For third shell 18 electrons 2s, 3s2, 3p, 6, 3d, 10. This is the maximum condition. By this way, in different suborbitals electrons are divided. Dear cadets, where electrons first enter divided by n plus L rule. If the value of energy of n plus L is low, in that case electrons first gradually enter in the higher energy level. For the value of n, here n is the principal quantum number. For first shell n is 1, for second shell n is 2, for third shell n is 3, for fourth shell n is 4. Here L is the secondary quantum number. For L, value is divided by different suborbital. For s orbital, value of L is 0. For p orbital, value of L is 1. For d orbital, value of L is 2. And for f orbital, value of L is 3. By combining the energy of n plus L, we can define the total energy in a shell. If the value is less, electron first enter. If the value is gradually higher, electrons are gradually entering in higher energy level. Dear cadets, by considering the energy of different suborbital, we arranged these suborbitals. First electron enter in 1s, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, then 5s. Gradually, electrons are entering in different suborbital by considering its total energy. Here, now, show the electronic configuration of aluminium, sulfur, and boron. Aluminium 13 electrons, sulfur 16 electron, bromine 37 electron. So you write down the electronic configuration by using dot or cross sign. In different suborbital. For aluminium, 1s2, 2s2, 2p6, 3s2, 3p1. For sulfur, you divide 16 electron in different suborbital by considering energy of suborbital. In case of bromine, you also divide this 37 electrons in different suborbital by considering energy. This is for your practice only. For this reason, here I don't want to discuss in this case. Dear cadets, from this discussion, several types of question may be set for. Here, first one, knowledge-based question. What is orbital? What is orbit? What is spectra? Orbital, where electrons are revolving. Orbital, where maximum probability of finding electron. Orbit, where electrons are revolving. Spectra, it is formed by transition of electron from one energy level to another energy level. It is detected by detector. There are second type question, understanding level. Show the spectral diagram of hydrogen. There are several spectral lines which are found from the transition of electron of hydrogen in different energy level. Suppose Lyman series, Balmer series, these series are found. Now, second understanding question, explain the energy of orbital. By considering n plus L rule, you can explain the energy of orbital. If the value of n plus L is low, in that case electron first enter. If the value of high, gradually electron entering. There is third type question, application based. There is an atom which is given X, and in the outermost electronic configuration is given 3d8, Ns2 here, n is the value of n is 4. So this is nickel. Now you draw the electronic configuration of X by considering different suborbital. 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2. This is the electronic configuration of the element which is given in the CQ question. Now, evaluate the properties of the compound formed by the STEM elements. The STEM element is nickel, it is metal. So, what will be the properties of the compound? Evaluate it. This is metal, it forms ionic bond, it dissolves in water. This type of properties are found by the element. Also, it shows color compound. Now, there is a CQ. You complete it and submit to me through online. There are two elements, scandium and cobalt. Now question, what is orbital? electron entering process in different orbital, electronic configuration of STEM elements, and the last question, form compound dissolve in which condition? It is metal, it form covalent ionic compound and complex compound and dissolve in polar solvent. By this way, you answer all the question and submit to me. Dear cadets, if any query you ask me, I will solve your question. Dear cadets, this is very crucial time. You stay home, stay safe, and stay fine with your family. Thanks a lot. Allah Hafiz.